Welcome everybody back to our third part of the introduction to agriculture in Egypt. As you remember, in the first part we were looking at the history of agriculture in Egypt, looking at agriculture from the pharaonic time to more or less the present day. In the second part we were evaluating the challenges that Egypt's agricultural sector is facing today. And now in the third part we want to evaluate one possible solution, which is like organic agriculture as composed to conventional agriculture. We're going to see, is it feasible to introduce like organic agriculture, and how would the two scenarios develop like over time of the next 10 years. So why organic agriculture? Usually there's a call for applying more sustainable ways of agriculture. Sustainability in agriculture, or sustainable agriculture, refers mainly to three things. One is, of course, economic profitability. Secondly is caring for the environment, and also caring for the social aspects of agriculture. So, as this is pretty ambitious, organic agriculture aims at those things, but organic agriculture is mainly determined by standards, like the EU standard for agricultural or organic production, or Demeter standard, which set like the conditions that agriculture has to fulfill in order to be considered organic. So this means that, for example, social aspects are more or less implicitly considered in those standards, but they are not a fixed requirement. So while organic agriculture aims to be fully sustainable, it is not exactly the same. So this is something that we have to keep in mind. Sustainable agriculture is ideal that we are striving for, and organic agriculture is like on the way to do this. We should recall the problems that we're facing in agriculture. Environmental concerns are mainly degradation of soils due to heavy inputs such as fertilizers and pesticides in the past 40 years, increasing salinity of the soils, as well as water scarcity and nutrient pollution of the water resources. Those problems also translate in economic problems, which is reduced yields of crops and also a strong increase in inputs and its cost. We're going to focus on one study that has been carried out by the Soil and More Foundation, which is called 100% Organic Study. This study basically compares a scenario of conventional agriculture in Egypt for the next 10 years as compared to a scenario of a shift to organic agriculture. They're testing the agriculture of both scenarios in both the old and the new lands for three different factors, we can say, which is the farm economics, the water footprint, and also the carbon footprint. Subjects of study are like seven different strategic crops in Egypt, which are sugar beet, sugarcane, cotton, maize, potatoes, rice, and wheat. For the following, as like looking at all seven of them would make our presentation rather lengthy, we're just going to focus on cotton and see how the scenario over the next 10 years develops in conventional as contrasted to organic agriculture. A crucial aspect in both types of farming is the soil organic matter. Why? It is really important because basically it keeps and maintains the physical conditions of the soil, such as soil structure, aeration, water holding capacity, nutrient holding capacity of the soils. So it serves basically as nutrient reserves of the soils. The soil organic matter acts like a sponge in the soil, keeping the water close to the roots of the plants, keeping it available for the roots, and also keeping the nutrients available for the plants, thus avoiding leaching and runoff of valuable nutrients, and thus also avoiding nutrient pollution of the water resources, of our main water resource, like the River Nile. Also, a good amount of soil organic matter increases the soil beneficial organisms, bacteria, insects that care for the resistance of the plants against pest diseases, and also like keep fixing the nutrients in the soil. The study compares for those 7 strategic crops the farming of them in both the old and the new lands. As you remember, old lands is mainly, when we refer to the old lands, we mean the narrow fertile strip along the Nile as well as the Nile Delta, where farming has been going on ever since the Pharaonic times and even since the pre-Pharaonic times, where the soil is rather clayey, the structure is moist, and the soil type is rather fine. While in the new lands, the newly reclaimed lands, we rather have sandy soil that is just like in the transition of reclamation and of like greening the desert, we can say, which means like taking agriculture out of the traditional zone along the Nile Valley more into the desert, using more new areas for agricultural production. Also, the irrigation methods are considered. The traditional flood irrigation is not very efficient in terms of like water use. Only 60% of the used water are absorbed and captured by plants. Sprinkler and drip irrigation have much better rates of irrigation efficiency, and there's actually a new type of irrigation as well, which increases like the efficiency as we have it in drip irrigation by another 50%, which is subsurface irrigation. Now, what is subsurface irrigation? Actually, it is taking the hose that is used like on the soil, on top of the land in drip irrigation, putting it 20 centimeter underground and having applying the water directly at the soils of at the roots of the plants. So what it does is actually it avoids evaporation. So this is how we can gain this increase of 50% of water efficiency compared to drip irrigation, which is really a huge achievement. However, this method is still like in the testing phase and not yet applied on the commercial scale. But for the coming years, I think we can safely assume that this new method will gain more momentum and be applied more and more like in agriculture. As said, the study looks at 3 main spheres: farm economics, water footprint, and carbon footprint. Farm economics relates to the actual cost of agricultural inputs, including subsidies that are needed to produce 1 ton of crop. So like how much input, like financially, do I have to give in order to have 1 ton of yield or crop? Water footprint asks how much water is consumed or evaporated or run off from the available ground and surface water body per unit of time, which means per year. This is what we're looking at here. Then the model that the study is using is a CropWatt model as provided by the United Nations. But I think we don't have to get into those details here. What is interesting for us is like what are the 3 spheres that we're looking at. Then we look at cotton, and then we see when we look at what are we expecting as a scenario for the next 10 years. The carbon footprint answers how much emission takes place in 1 year, or like to produce 1 ton of biomass. And here, one thing that is important to keep in mind, that agriculture has a potential to be both a net emitter of carbon dioxide, which means contributing to climate change, but also being a sequester of carbon dioxide, which means it has a capacity that well-managed, fertile, healthy soils can capture carbon dioxide from the atmosphere and thus reduce climate change and anthropogenic greenhouse gas effect. So here is really a crucial issue for climate change. So now let's look at the results, which means let's look for our exemplary crop of cotton, how it is doing in both conventional and organic agriculture. First, we look at the cost in the new land specifically. The blue line is a conventional, the red line is organic, and we have here in the diagram, we look at the years between 2011 and 2020. and at the y-axis we see the cost per ton, which means the cost of production per ton of yield. In conventional agriculture we can see that those costs are increasing over the next 10 years. Now why is that? Mainly because we can assume that while we want to keep the yields stable over the next 10 years, two things are changing. First of all, as the resource base and the soil organic matter in the soils is decreasing, we need more and more input to keep the same productivity of the soils, which means from year to year we have to apply more fertilizers to acquire the same yield. And secondly, besides of the amount that we have to put in the land, we can also assume that given that the resource base is shrinking, not only in the soil itself, but like also globally, the cost of production for fertilizers will increase, and thus the price for fertilizers will increase. So we have two effects that lead to an increase in price in conventional agriculture. In organic agriculture, we see at the beginning that it is more expensive, but then slightly decreasing cost. This is mainly because we think of a scenario where we're having a farm in transition, just like changing from conventional to organic agriculture. The inputs that we're having there is not like synthetic fertilizers like in the conventional scenario, but organic agriculture mainly uses compost for fertilization. Compost is very beneficial because it is increasing the soil organic matter in the soil. It improves the water holding capacity, and also, as said before, the soil organic matter holds nutrients. So the soil is built up from year to year, which means we don't have that much inputs. We have quite a lot in the beginning, but then as we have to apply less and less compost from year to year, as from year to year the productivity or like the quality of the soil increases, we see that the costs are slightly decreasing over time. So at some point, and this is really remarkable and notable, at some point, here it is anticipated in the year 2018, the cost of organic will meet the cost of conventional production and then get lower. So this is interesting because a lot of people say, well, organic cannot feed the world simply because it's something for the affluent that like ordinary or like even poor people cannot afford. But we see at some point in the future organic agriculture will actually be cheaper than the conventional case. This is something that we really should keep in mind and that would be interesting to monitor over the coming years. For the carbon footprint, we also have an interesting scenario here. In the conventional, we see that the emissions are pretty much the same over the next coming years, while in organic, the curve is more curved shape. So in the beginning, we see that the carbon dioxide emissions per ton of production are in the minus. What means in the minus? In the minus means that the soil is actually sequestering the carbon from the atmosphere, which means it is not emitting, but it's taking and capturing carbon dioxide. And then once the capacity for sequestration is like totally absorbed, there are emissions which are, however, significantly smaller than in the conventional scenario. In this diagram here, we see this a bit more clearly. We have here, again, our timeline, the kilogram of carbon dioxide per ton of production, and then we compare the conventional with the organic case. We see that even from the beginning, that the sequestration in organic agriculture is pretty high. Like especially in the beginning, we apply compost to our soil, which means it's like fresh material. It has the capacity to absorb a lot of carbon from the atmosphere, and over the years, more carbon gets absorbed, so the capacity decreases slightly until it is fixed, and let's say the capacity is taken up. For energy, we see it's like both in energy is like the green line. It is more or less in conventional and organic. This is mainly because energy is considered as the energy that is needed, fossil fuel that is needed for irrigation purposes, which is more or less the same. However, there are some effects which we will see soon. We see that here the orange part is the soil carbon losses. This is the emission that, and this is something that only exists in the conventional case. While organic is sequestering the carbon, the soil in conventional is actually emitting carbon dioxide from the soil. So this is why we have a little bit uneven picture here. The blue water footprint, comparing the two scenarios, blue water is the water that is taken from freshwater resources like groundwater or Nile water. In the conventional case, it is stable, staying the same over the next 10 years, where we see again a decrease in organic agriculture. This decrease can also be explained again with the soil organic matter. The compost is building up soil organic matter, thus developing the soil over the next 10 years, thus, let's say, growing the sponge where the water is captured in the soil. So the water is kept in the soil, and over the years, as the soil builds up, more water can be captured in the soil, which means we need less irrigation, the irrigation efficiency increases, and we need less water inputs. So here again, also we see at the moment, we need more input in the organic field, we can say, which means like, remember, we are a farm which is in transition. At the moment, we have to have a lot of inputs to convert our land. As the soil develops over the years, the water holding capacity of the soil increases, and after 10 years, we need actually less water than in conventional agriculture. Here we can see the total cost in both conventional and organic case. And at the side here, we can see the different cost factors in both scenarios. And what is significant here is especially the fertilizer, which is increasing in the conventional scenario over the 10 years. You see that this area is growing, while in the organic case, it is staying the same. Which means like, okay, we're putting in the compost over our land, and this doesn't really increase our cost of production. Pesticides cost is also a very important factor. You can see, okay, the cost for pesticides in the coming 10 years remains stable. However, as organic is defined by standards, as said before, and those standards usually say, okay, no chemicals, no pesticides in organic agriculture. Why? Because we care also for the biodiversity. So those costs does not occur here at all. Also significant is the orange area that we're having here, which is significantly larger in organic agriculture, and this refers to labor cost. So of course we can say like organic farms are usually smaller, less mechanized than the conventional farms. So there's a lot of more things have to be done by hand, so it needs a lot of more labor input. So the negative aspect is this, as you have increased labor cost on the organic farm. But let's try to see things from a positive point of view. So increased labor also means more employment, and since agriculture is usually in rural areas, it means like more employment, more income for people in rural areas. So from a development point of view, from the social point of view, which is, as said, regarded in sustainable agriculture, this can be seen as a benefit. It can be seen as a benefit and as a drawback, but let's keep things positive. And one thing that is also important, you see that the yield here, as said before, we're just trying to keep things stable. We're trying to keep the yield stable. While, again, in transition with our farm, the soil quality develops over time, it gets better, so we can expect to have increased yields. So here we have the case that we actually proved two objections of organic agriculture to be wrong. First, the cost case, case, it is too expensive, people cannot afford it. We saw that actually over time, as the cost of the input increase, organic agriculture will be more competitive and eventually reaching the point where it is like cheaper than conventional. And also secondly, there's not enough. So this is also another common objective against organic agriculture. But we can see it as we care for the soil, as we develop our land, actually the yields increase. So we have the possibility to feed more people actually. To the water foot, those three water types here, like green water, which refers mainly to the rainwater that is kept as moisture in the soil, and well, it is marginal. It's basically not occurring because, as you know, rainwater is like something that is not really significant or in Egypt. Blue water is the amount of freshwater resources from groundwater or from the Nile, for example, and gray water is like the polluted waters, runoff, we can say. So in the beginning, here actually we see what we just see again in a different form, what we have seen before. In organic, in the beginning, we need more water input because our soil is not that developed, which decreases over time. And the gray water actually is not existing anymore, which means we don't have polluted water. Because we assume, just to remind you again, we assume that our soil quality is like developed. Also, we assume that organic farms are using more efficient ways of irrigation. For example, you hardly find flood irrigation in an organic farm. So we will not have those runoffs. The water applied is water used. While the gray water in conventional is continuously high due to the fact that due to traditional methods of flood irrigation, and also the efficiency is very low, which means you have a lot of runoff. There's not much soil organic matter in your farm. So the water that you apply to the land does not mean that everything is used, but a lot actually just is washed away. And this is the trouble that we're having. It is washed away and it takes with it a lot of nutrients and a lot of the soil organic matter that we're having. So thus like degrading the soil more and more. So let's come to the conclusions. What have we learned here? We saw that as the source of natural resources decreases, the cost of production increase. Natural resources means again the soil organic matter. And the yield and the resource use efficiency are the predominant factors for determining the cost per ton of production. In organic, we saw that the cost decrease as we are developing the soil and as we need a lot of input in the beginning in terms of compost. We can reduce our inputs over time, which means we also have less cost for the inputs, which then again means decreasing cost of production of like ton of crop that we are receiving. While in the conventional case, we saw that as resource base is depleting, we need more inputs, which means more fertilizers, and we can also expect that the cost for them will increase over time. This just confirms that the inputs have a major share in the total cost of the production. Another aspect that showed like 2 slides before is labor empowerment. Here again we see it from the positive side. Labor means cost, but it also means employment and development for rural areas. So it depends what we want. The carbon footprint of the two agricultural systems in terms of greenhouse gas emissions is more or less the same for energy use as we saw, but it is higher for conventional agriculture overall because of the emissions created through the fertilizer production, and also as the soil emissions increase over time. So as less soil organic matter is left in the soil, like it cannot, the carbon dioxide cannot be captured, and the soil actually becomes to a net emitter of greenhouse gases. While the compost that we apply in our organic farm to sequester carbon dioxide from the atmosphere, so making it actually a sink for carbon dioxide, and thus actually being mean in the fight of climate change. The water footprint is higher in the conventional agriculture, as we saw, and this is true not only for cotton but also for maize, potatoes, rice, sugar beet, and sugarcane. The only crop where it is actually higher in organic agriculture than in the conventional one is for wheat. We didn't look at this case in that much detail, but I think it's an interesting information here. Also, there's a general underestimation of greywater footprint for conventional crops because the model does not account for the runoffs that occur from pesticides. And pesticide and fertilizer runoffs are really problematic. They're reducing the resource base of the soil, but also, especially pesticides, are accumulating in the life cycle of the environment and thus accumulating more and more through the system. Well, we can say what we know from the presentation before about the problems of agriculture, that business as usual is not an option. Agriculture is at the crossroads. Something has to be done, and it has to be done for several reasons, because of the cost for us, the cost for the environment. Also because to sustain a future that our children can live in, we should shift to more sustainable ways of agriculture. So I hope you enjoyed those 3 presentations and you gained some new insights about agriculture in Egypt. And I hope also that the presentations gave you some food for thought to reconsider the matter, and I thank you very much for listening and say goodbye.